Hello. In our last lesson, we learned about the length and perimeter. And if you can remember, we defined length as the distance between 2 points. While perimeter, we said it refers to the distance all round and outside of a shape. Let's see if we can still remember. We said from point A to point B is length. And for perimeter is when you are given a two-dimensional figure and you are told to find the length all round the outside of that figure. Figure A, B, C, D, as you can see, is a rectangle. And for you to be able to find the perimeter, we said you are supposed to add the distance all round. That means you're supposed to add the distance of the length and the width. And we said you multiply by 2 so that you get for the all round. That is the distance round outside the plane figure. That is if you are moving from point A to point B, then to point C, to point D. That is the perimeter along the outside of the figure. But if you want to find, what if you want to find the surface inside the figure? The amount of surface inside that figure. What do we then do? So today we are going to learn about how to establish this amount of surface inside a two-plane figure. Let's look at a figure called the square. And in our last lesson, we said the square has all the sides equal. So let's take an example of a square measuring 1 centimeter by 1 centimeter. What our interest is, we want to find out the amount of space that this figure will occupy. That is the space inside the square. How do we go about it? Let's, for example, divide this square into small squares. Let us divide this enlarged square measuring 1 centimeter by 1 centimeter into small squares of a millimeter, measuring 1 millimeter and 1 millimeter. This one small square is what is measuring 1 millimeter by 1 millimeter. If we can be able to count the small squares inside this enlarged one square measuring 1 centimeter by 1 centimeter, you realize that on this other end, we have 1, we have 10 small squares measuring 1 millimeter by 1 millimeter. If we also count on this side, you realize that we also have 10 small squares measuring 1 millimeter by 1 millimeter. Then, if we count all the number of squares that are inside 1 centimeter square, we realize that we will get 100 of them. So inside 1 centimeter by 1 centimeter, are 100 squares measuring 1 millimeter by 1 millimeter. Then the question that we are supposed to ask ourselves is, what are these 100 squares? What are these 100 squares? This is what we are referring to as the area. This is what we are referring to as the area. Area means the amount of space inside a two-dimensional figure. The amount of space occupied by a two-dimensional figure. So we have taken an example of this 1 centimeter square that is enlarged, and we see that they have 100 squares measuring 1 millimeter by 1 millimeter. Then it takes us to another point. What are the units that we use to measure area? In our last lesson, we said that length is measured using a metric system, which the common unit is a meter. And we said we have in the metric system we have the kilometers, we have the meters, we have the centimeters, and we have the millimeters. In area, we measure area using square units. We measure area using square units. And the common units that we have in area is kilometer square, meter square, centimeter square, and millimeter square. So the units of measuring area is square units. How do we get the square units? We have seen, using our previous example, that one small square measures 1 millimeter by 1 millimeter. For us to be able to get the area inside this, we say 1 millimeter by 1 millimeter. What will that give us? 1 square millimeter. It will give us 1 square millimeter. This is what we are saying that we use to measure the area. Square millimeters, square centimeters, square meters, and square kilometers. How do we change from square millimeters to square centimeters, or even to square meters or square kilometers? Kilometers, square kilometers is the larger unit here, followed by square meters, then square centimeters, and finally square millimeters. If we are converting from a larger unit to a smaller unit, you realize, if you remember from our last lesson, that we multiply. A larger unit to a smaller unit, we multiply. But if we are moving from a smaller unit, converting it to a larger unit, we said you divide. You divide. So let us look at the differences, or how to convert from one unit to another. For us to get into square centimeters, we normally multiply 1 centimeter by 1 centimeter to give us 1 square centimeter. And we know that 1 centimeter has 10 millimeters. So if we are supposed to multiply 1 centimeter by 1 centimeter, that means if we are supposed to convert, then we are supposed to have 10 millimeters by 10 millimeters to give us 1 square centimeter. So then we have under 1 square centimeter, we have 100 square millimeters. Square millimeters. Also, under 1 meter, we have 100 centimeters. How do we get square meters? You realize that if we multiply 100 centimeters that make 1 meter by 100 centimeters of the same, it will give us 10,000 centimeters square. So 1 meter square is equals to 10,000 centimeters square. We know from our previous lesson that 1,000 meters gives us 1 kilometer. How do we get a square kilometer? Then 1 square kilometer has 1 million square meters. 1 million square meters. We have another unit that we also use to measure area, and this one is normally used to measure the amount of land that we call an hectare. An hectare, this measurement here gives us an hectare, 100 meters by 100 meters. So if we multiply 100 meters by 100 meters, we get 10,000 meters square. So what does that tell you? That 1 hectare is equals to 10,000 meters square. Let's now look at examples of how to convert one unit to another using this information. If we are supposed to convert from one unit to the other, this is the summary of how we are supposed to do it. So let's look at an example. Let's look at these examples of how to convert one unit to the other. We have 0.248 meters square meters into square centimeters. So you realize that we are converting a larger unit from a larger unit to a smaller unit. And we have said that if you are converting from a larger unit to a smaller unit, you multiply. So what are we going to do? We said if you are moving from meters to centimeters, you multiply by 10,000. We'll have 2,480 square centimeters. What about the 38,100 square millimeters into square centimeters? Because you realize that this one, we are moving from a smaller unit to a bigger unit. And we are saying if you are moving from a smaller unit to a larger unit, we divide. The other thing that you need to understand is how many square millimeters make 1 square centimeter. So from our summary, we realize we divide by 100. That will give us 31 square centimeters. Square centimeters. Having understood that, let us now move to see how to find the area of two-dimensional shapes. The common figures that we look at are the rectangle, the triangle, and the square. So let's look at how to calculate the area, the amount of surface covered by these shapes. We are asked to find So let's look at how to find the area of a rectangle. A rectangle, we have said in our last lesson that the opposite sides are equal and they are parallel. This is an example of a rectangle. A rectangle The area of a rectangle is given by length times base. This is referred to as the length, and this is referred to as the base. An area of a rectangle is calculated by length times the base, abbreviated as L times B, which will give us LB. If that is the case, then how do you calculate the area of this rectangle? So you realize that our base, our base in this case is 4 centimeters, and our length is 6 centimeters. So the area of this rectangle will be 24 square centimeters. And remember, we have said that the units of area is square units. You must indicate that this is square centimeters. This is square centimeters, having multiplied centimeter by centimeter. The answer will be 24 square centimeters. So let's look at how to calculate the area of a square. We have said the square has all sides equal. We have length measuring, we have length, and this side is also length, abbreviated as L. Let's assume that our square measures 4 centimeters by 4 centimeters. What will be the area? We have said the area of a square is given by length times, which will give us L squared. In our case, length times length is 4 times 4, which will be 16 square centimeters. So the formula of calculating the area of a square is L times L, which is L squared. What we are supposed to do when we get here is to substitute the value of our L, which is 4, and then 4 here, and it will give us 16 if you calculate, if you multiply using a calculator. Triangle is a three-sided figure, and we have types of triangles. We have a right angle triangle. We have an isosceles triangle. Isosceles, we said from our previous lesson that it has 2 sides equal. So because it has the same dashes, it means that this side and this side are equal. So how do you calculate the area of a triangle? Area of a triangle is given by half base times the height. So this side refers to the height, while the bottom side is referred to the base. In an example of an isosceles triangle, the dotted line is the height, and this one that is written as B is the base. So always a height and a base meet at a right angle. They meet at a right angle. So if you want to know which side is the height and which side is the base, you look at the side where the height and the base meet at a right angle. So given an example, we have a triangle measuring 7 centimeters by 5 centimeters. What will be the area? We are told that the area of a triangle is given by a half base times a height. If you look correctly, you realize that our height is measuring 7 centimeters and our base is 5 centimeters. Then we will substitute our values in the formula. A half times 5 times 7. 5 goes into 2, or 2 goes into 5, 2.5 times. That is remember, the area is given in square units, so our answer will be 17.5 square centimeters. Before you calculate the area, you must ensure that the units are same. If they are millimeters, they should all be millimeters. If they are centimeters, they should all be centimeters. But in a case where one measurement is in millimeters and the other is in centimeters, you are not allowed to proceed unless you change the units into one common unit. For example, let's take an example of this figure here. This is still a triangle, and the area is given by a half base times height. You realize that the base is given in millimeters, while the height in centimeters. We are supposed to change so that we have common units. Which one are we going to change? We will change the base into centimeters. We said in our last lesson that 10 millimeters equal to 1 centimeter. So we will divide by 10 so that it gives us 3 centimeters. Now that we have 3 centimeters, let us calculate now the area, substituting in the formula. So 2 goes into 4 2 times. It will give us 6 square centimeters. 6 square centimeters. So what have we learned? That for a So these are the formulas for calculating the area. We have learned that for you to be able to calculate the area of a rectangle, you use the formula length times base, which will give us LB. For a square, we say you multiply length by length, it will give us length square. And for the area of a triangle, we multiply by half by base by height, which will give us a half base times a height times the height. So these are the formulas that we use in calculating the areas of the three figures: rectangle, square, and the triangle. The next that we want to look at is finding the area of composite figures. So before we continue, let us understand the meaning of this term, composite shape or composite figures. Composite shape or composite figure is a figure which you can get by connecting 2 or 3 or more basic shapes. An example: is a figure like that. An example is this figure. It is called composite in the sense that if you drop a perpendicular line from up here down here, you realize that we now have two basic shapes. We have a square and we have a triangle. For us to be able to calculate the area of this figure, we won't be able to calculate directly, but we are going to get the area by calculating first the area of A and then the area of B and adding them together. So the area of this figure is the area of A plus the area of B. It is not always that we add small basic figures to give us the area of a composite shape. Sometimes you are required to subtract. We either add or subtract. An example of a composite figure where we need to subtract is an example of a figure where we need to subtract is this. This is, if we join these points here, you realize that this one will make a full rectangle. A full rectangle. But as from a drawing, it is actually a carved out rectangle. There's a part of a rectangle that has been carved out. So the area that we are supposed to find is the area of this. For us to find the area of, let's call this one A and this B. For us to be able to find the area of B, we are supposed to find the area of all this figure, the rectangle. Then we remove the area of A. We will remain with the area of B. Let's take, for example, that this rectangle has these measurements. It has the base, 10 meters, then it has the length 10 meters, and then the base 6 meters, and the height for triangle A is 4 meters. How are we going to get the area of B? So I've said we'll find the area of the rectangle, then calculate the area of the triangle and subtract. So what is the area of the rectangle? It is given. It is substituting in the formula. Length times base will give us 10 meters times 6 meters, which will be 60 square meters. That is for the rectangle. The area of the triangle is given by a half base times the height. Because this is opposite and they are equal of a triangle, it means that this side is also 10 meters. And we have said the area of a triangle is calculated using the formula a half base times the height. Let us substitute in our formula the values. Two goes into 4 2 times. That is the area of the triangle. So the area of B will be 60 minus 60 square meters minus 20 square meters. And we have said 60 square meters is because of the rectangle and 20 because of the triangle. When we subtract the two, we have the area of B, which is 40 square meters. That is finding the area of a composite shape by subtraction. Let us take an example of one by addition. We have this figure here. Sorry. We are given this is 3 millimeters, and this side is equal to this side. Then this is 1 millimeter, this is 1.2 millimeters. You realize that if we drop a perpendicular line down there, they make two figures, A and B. So for us to be able to get the area of this figure, we are supposed to calculate the area of A, add the area of B. So the first thing that you're supposed to do is to find the measurements of the missing lengths. This part here, we are told is equal to this part, which then will be also 3 millimeters. Then that will also be 3 millimeters. If this is 3 millimeters and this is also 3 millimeters, what does it tell us? That A is a square. So the area of the square we have said is length times length, or length squared, which will give us 3 millimeters times 3 millimeters, which is 9 millimeter square. What about B? You realize that B is a rectangle measuring 1 millimeter by 1.2 millimeter. We are saying it is a rectangle because the sides are not equal. So B, we multiply using the formula of calculating the area for rectangle, which is length times base, which is 1 times 1.2 millimeters, and that will give us 1.2 square millimeters. The area then, if we add the area of A and B, will be 10.2 millimeters square. That is calculating the area of a composite shape by addition. Let's look at another shape, another triangle, a scaling triangle, like this. This is 2.4 millimeters. Here is 2.2 millimeters, and here is 3 millimeters. How do we calculate the area of this figure? So again, this area, we get it by subtraction. Subtraction because you're supposed to remove the side that is not, the surface that is not required. We will use, remember, we said that the area of the formula of calculating the area of a triangle is half base times height. So this is our height and this is our base. For us to be able to calculate the area of B, this is A. For us to be able to calculate the area of B, we need to calculate, supposing we need to calculate the area of triangle X, Y, Z, the bigger triangle. Then we subtract the area of A for us to be able to get the area of B. So for the bigger triangle, the base is, we add the two, 3 millimeters and 2.4 millimeters. When we add, we get the base to be 5.4 millimeters. So 2 and 2 cancels. We get the area of this larger triangle . the larger triangle XYZ to be 5.4 millimeters square. Now, we need to calculate, because we don't need, remember the area that we have got is for the whole of this triangle, but we are interested in the area of B. So that means the part that is not required is A. So we need to find the area of A, then we subtract to give us the area of B. So the area of B, we have the base being 3 millimeters. It is only from here to here, 3 millimeters. And then we have the height, which is still 2 millimeters. 2 and 2 also cancels. The area of A then is 3 millimeters square. So the area of B is 5.4 square millimeters minus 3 square millimeters. And that will give us 2.4 square millimeters. This is calculating the area of a composite shape by subtraction. So we are asked, let's look at an example of another composite figure. We are told to calculate the area of the shaded part. We have a larger rectangle that is measuring 10 kilometers by 6 kilometers, and then inside there is a part that is not covered that is measuring 2 kilometers by 7 kilometers. We are told to calculate the area of the shaded part. What are we going to do? So this is calculating the area of a composite figure by subtraction, because you realize that the surface inside is not what is required. So we will calculate the area of the larger triangle. If we of the larger rectangle. If we calculate the area of the larger rectangle, we'll have all the surface covered, and then we will calculate the area of the smaller rectangle, and that is the area that is not required. That means we shall then subtract. So the area of the rectangle, we have said it is length times base, which then will be 10 kilometers multiplied by 6 kilometers. That will give us 60 square kilometers. That is the area of the whole rectangle. We now calculate the area that is not required. The area that is not required is 2 kilometers by 7 kilometers. If we substitute in our formula, then it will be 7 kilometers times 2 kilometers when it is length times base, and it will give us 14 kilometers, square kilometers. So for us to be able to get the shaded part, we subtract 60 square kilometers minus 14. And that will give us 46. That will give us 46 square kilometers. So we have subtracted the region that is not required, and now we are remaining with the surface that is required, which is 46 square kilometers. So that marks the end of our lesson today. Let us remind ourselves of what we have learned. We have learned that today about area, and we have said that area is the amount of surface occupied by a two-dimensional figure. And we have said that area is measured using square units, and we said the other time that the system of measuring is in metric units, which we have kilometers, meters, centimeters, and millimeters. But because area we are using square units, we will measure using square kilometers, square meters, square centimeters, and square millimeters. We have tried to look at how to convert one unit to the other, and we realized that if you are converting from a larger unit to a smaller unit, you multiply. And if you are converting from a smaller unit to a larger unit, you divide. We have also looked at how to find the area of two-dimensional figures, that is a rectangle, a triangle, and a square. And we said the formula of calculating the rectangle is length times base, and for square is length squared, and for the triangle is a half base times height. We have went ahead to also look at how to calculate the area of composite figures, and we said we either use addition or subtraction method, where we calculate the area of a larger figure, then we subtract the area of a smaller figure, if that is by subtraction. Or if the composite figure is made up of two basic shapes, then we add the areas of those two basic shapes. Thank you.